Hi everybody, my name is Weixu Wang, and today I will talk about my DSAR project. So this is the residential energy using in the US, the research I did, and this is the breakdown of the residential energy used by devices. We can see that the air conditioning and heating takes the biggest part of the out of the like about 46% and make a pie chart on the right, and this is my background of the residence. My apartment is 2B2B, and it's me only living here. My roommate is not here. So I also did found the data which fits the apartment living situation and the average energy use about this apartment labor. So the average electricity used by my devices, I did the research and these the 8 different devices I used the average level, and the other content I research is that on average the Minnesota residents spend like 21% lower than the national average for the electric bill. And those are all the devices I measured. And this is the energy use log. When I try to measure this log, the use the log to measure the energy, I just like post the time when I did not use it, except the mini fridge because it keeps on for 20 or 24 hours each day. And I just like carefully to record the time used and the energy shows on the measure. So the explanation of the calculations. So for the constant, I just read the power, then multiply the average time used each day, and to get the average power used for each day. And then for variable power, because I have the total energy used, so I divide it by the total time I use to get the average power, then multiply the average time used per day to get a result. For light, I just figure out the unit and use it to multiply the hours used to get a result. So these are the three differences, the differences of three types of power. So for variable, it's just like it's easy to adjust and it's unstable. It's like variable. And for constant, it just like it's controlled, so the output power remains constant. And for the quantum power, is count because it just like it's wasted. All the power is wasted. That's why it's called the name. And this is my energy use summary, and those are all the data. And for compared to the average, I could get the summary like compared to the average energy use. My measured values show that my energy use is lower than normal in total, but because my humidifier use higher energy than average, so I turn it on almost 40 hours per day. You can see that it's here, it's 40 hours, and the average humidifier use 11 watts, but mine use like 26. It's like twice than it. So it uses a lot of energy than the normal situation. So if I reduce the time to use it every day by like turning it off when I go outside, so I will spend like half less time compared to the current situation. And this is my calculation. And in the result, I almost like save 5% of total energy use. And this is my reference list. Thank you.